Pile groups. When the capacity of a single pile is not sufficient to take the structural load, then a pile group is preferred. The piles in a group should be spaced such that the load-bearing capacity of the group should not be less than that of sum of individual pile capacities. The minimum spacing of piles, as recommended by IS code 2911R, is equal to 2.5 times of diameter for point-bearing piles. It is equal to 3 times the diameter for friction piles, and it is equal to 2 times the diameter for compaction piles in loose ends or fills. Efficiency of pile group. Efficiency of pile group equal to actual group capacity of piles divided by sum of individual pile capacities. For friction piles and clays, efficiency of pile group equal to 2 into m plus n minus 2 into s plus 4d divided by alpha pi d into mn. Here m is the number of rows in the pile group and n is the number of columns in the pile group, s is the spacing, d is the diameter, alpha is the adhesion factor, d is the diameter, and m and n are number of rows and number of columns. For friction piles and sands, efficiency of pile group equal to 1 minus theta by 90 into n minus 1 into m plus m minus 1 into n divided by m into n. This equation is called as converse-Lebesgue equation. Here theta equal to tan inverse d by s, where d is the diameter of pile and s is the spacing of piles. M is the number of rows and n is the number of columns. Capacity of pile groups. In case of clayey soil, to estimate the capacity of pile group, we have to consider two criteria. One is individual pile failure and the other one is block failure. By calculating the sum of capacities of individual piles, we can find the capacity of the pile group based on the individual pile failure. And to find the group capacity based on the block failure, we have to consider the pile group as a single block and then we have to estimate the capacity of the group. So here AG is the area of the pile group and ASG is the surface area of pile group. After finding the capacity of pile group based on both the criteria, then we have to compare and find the smaller one. The smaller one will be taken as the capacity of pile group. In case of sandy soil, we have to find the sum of capacities of all the piles and then we have to estimate the efficiency of pile group using the converse-Lebesgue equation. Since the efficiency of pile group is the ratio of actual group capacity to sum of individual pile capacities, we can find the group capacity which is equal to efficiency of pile group multiplied by sum of capacities of all the piles. Settlement of pile groups. In case of porous soil, we have to use the equivalent draft method to estimate the settlement of pile group, for which we have to assume a raft footing at a depth of 2/3 L from the ground level. And we should assume that the load is dispersed in 2:1 manner from the base of the raft footing. So here increase in effective stress can be determined by taking the ratio of allowable load divided by load on which area on which the load is distributed, and then now we have to estimate the initial effective overburden pressure at the center of the clay layer. Then using the normal consolidation settlement equation, we can estimate the settlement of the clayey soil. But if the thickness is more than 2 meter, it is better to divide the thickness of clay layer into smaller thicknesses of a number of layers with thickness around 2 to 3 meter. Then we have to find the sum of these settlements and it can be reported as the capacity of the pile group. In case of cohesionless soil, capacity settlement of pile group equal to settlement of single pile multiplied by 4 Bg plus 2.7 divided by Bg plus 3.6 whole square. Here Bg is the width of the pile group. And this value should never exceed 16 times the settlement of single pile. Negative skin friction. When a pile is driven into a soft compressible soil like recent fill or loose sand or unconsolidated clay, the pile will be subjected to a downward drag force due to consolidation of the strata. This downward drag force is called as negative skin friction. So for single piles, negative skin friction equal to alpha into Cu bar into As into N, where alpha is the adhesion factor, Cu bar is the average cohesion, and Asn is the surface area of the pile in the negative zone. And if it is sandy soil, then negative skin friction equal to K into gamma Lc by 2 into tan delta into As into N. So this is nothing but frictional resistance in the negative zone. And if it is a pile group, then we have to find the negative skin friction on a single pile. Then we should multiply with the number of piles. Then we should consider it as a block, and then we have to find the value of Pg into Lc into Cu plus gamma into Lc into Ag. Here Lc is the length or depth of recent fill. So after finding these two values, higher value will be taken as the negative skin friction of pile group. So if the pile is subjected to negative skin friction, then the factor of safety will be reduced. So here factor of safety equal to ultimate load divided by allowable load plus negative skin friction. Pile load test. It can be performed either on a working pile or on a test pile. Load is applied in increments with the help of a reaction frame and hydraulic jack. The load settlement curve is then plotted. So from the load settlement curve, we have to find the ultimate load carrying capacity of the pile. So if there is any pronounced peak, then we can take the corresponding point as the ultimate load. But if there is no pronounced peak, then we have to use either a single tangent method or a double tangent method. If there is any straight line portion, then we have to extend that straight line portion to intersect the x-axis. So wherever it is intersecting, that value will be taken as ultimate load carrying capacity. If there are two straight line portions, then we have to extend both the straight line portions of the curve. Then from the intersection point, we have to draw a vertical. Wherever this vertical is intersecting the x-axis, that will be taken as the ultimate load carrying capacity of the pile. There is one example. A group of 16 piles of 50 cm diameter is arranged with the center to center spacing of 1 meter. The piles are 9 meter in length and are embedded in soft clay. The cohesion is 30 kPa and adhesion factor is 0.6. Determine the ultimate load carrying capacity of the pile group. Neglect end bearing resistance. So here there are 16 piles and the diameter is 50 centimeter. It is arranged with a center to center spacing of 1 meter. So the width of the pile group is equal to length of the pile group because it is a square in section, which is equal to 3 times the spacing plus diameter. So it is coming as 3.5 meter. Then by considering the individual pile failure, ultimate load carrying capacity of single pile equal to CNC into AB plus alpha into Cu bar into As. Here Cp is the cohesion at the pile tip, NC is 9, AB is the area of the pile at the base, alpha is the adhesion factor, Cu bar is the average cohesion, and As is the surface area. So since it is mentioned to ignore the end bearing resistance, we should consider only the frictional component, which is equal to alpha into Cu bar into As. Then we have to find the sum of capacities of all the piles, which is equal to capacity of single pile multiplied by number of piles, which is 16. Then by considering the block failure, capacity of pile group equal to CNC into AG plus alpha Cu bar into ASG. Here AG is the area of pile group and ASG is the surface area of the pile group. So capacity of pile group equal to, by ignoring the end bearing resistance, we will be getting Cu bar into ASG. Cu bar cohesion is given as 30 and surface area of pile group, which is equal to perimeter into length. So 2 into 3.5 plus 3.5 into 9. It is coming as 3780 kilonewton. Then we have to take the smaller of these two values as the capacity of pile group. Another example, a square group of 10 piles was driven into soft clay extending to a large depth. The diameter and length of the piles are 30 cm and 9 meter respectively. If unconfined compressive strength of the clay is 90 kPa and the spacing is 90 cm center to center, what is the capacity of the group? Assume the factor of safety as 2.5 and adhesion factor of 0.75. Take NC equal to 9. So here also it is a square in section. There are 9 piles and the soil type is soft clay. So here pile diameter is given as 30 cm and length is given as 9 meter. Here unconfined compressive strength is given. So cohesion of soil equal to unconfined compressive strength divided by 2, which is coming as 45 kPa, and spacing is given as 90 cm center to center. So here we have to estimate the capacity of the pile group. So here since it is clay soil, we have to consider two criteria, that is individual pile failure and block failure. For individual pile failure, we have to estimate the capacity of a single pile and then we have to multiply with the number of piles. And in case of block failure, we have to consider the pile group as a single block, and for the block we have to find the area as well as perimeter. Then we will be getting the capacity based on the block failure criteria. Then we have to compare these two values and smaller value will be reported as the capacity of pile group. So to estimate the allowable load bearing capacity of the pile group, we have to divide this ultimate load carrying capacity with the factor of safety. So ultimate load carrying capacity divided by factor of safety, which is given as 2.5, will be getting the allowable load on the pile group. Next example, a square pile group of 16 piles passes through a recently filled up soil of 5 meter depth. The pile diameter is 300 mm and pile spacing is 0.8 meter. If the unit cohesion of the material is 18 kPa and unit weight is 15 kN per meter cube, compute the negative skin friction on the group. Adhesion factor is given as 0.6. So here we have to estimate the negative skin friction, and here recent fill is for a depth of 5 meter. So here we have to find the negative skin friction of a single pile, which is nothing but frictional resistance in the negative zone. So frictional resistance is nothing but alpha into Cu bar into AS. So here for the negative zone, alpha value is 0.6 and surface area is perimeter into length and average cohesion is 18. So this is the negative skin friction on a single pile. Then multiply with the number of piles, so that we will be getting the negative skin friction on the entire pile group. So this is based on the individual pile failure. Then by considering the entire pile group as a block, then width of pile group equal to 2.7 meter, and we have to find the area of the pile group and then perimeter of the pile group. So by taking the area of the pile group and perimeter of the pile group in the equation, we can calculate the value of negative skin friction on the entire group, and then the higher value of these two will be taken as the negative skin friction of the pile group. Next example, a pile group consisting of 9 piles, 30 cm diameter and 10 meter length, and is arranged in 3 rows at a spacing of 0.75 meters center to center. The piles are driven into a deposit of clay. The properties of soil are C equal to 100 kPa, gamma equal to 20 kN per meter cube. Determine the safe load on the pile group. Take factor of safety of 3, adhesion factor 0.6 and NC value 9. So this is a similar problem. Here also we have to consider both the criteria, individual pile failure and block failure. Then we have to calculate the capacity of a single pile. Then we have to multiply with the number of piles. So in the block failure criteria, we have to consider the entire pile group as a single block, and then we have to find the area of the pile group as well as perimeter of the pile group. Then after finding the capacity of the pile group based on both the criteria, then we have to take the smaller value as the capacity of the pile group. So here there are 9 piles with diameter 400 mm, length 10 meter. But here the soil type is sandy soil. So in case of sandy soil, the procedure is different. Here we have to find the capacity of a single pile using the normal procedure. Then we have to multiply with the number of piles to get the sum of capacities of all the piles. After that, we have to estimate the efficiency of pile group based on the converse Lebesgue equation, where theta equal to tan inverse d by s. Here diameter is given as 400 mm and spacing is given as 1 meter. So by taking these two values, we can estimate the value of theta and then efficiency of pile group. Here number of rows and number of columns are same, which is 3. Then after calculating the efficiency of the pile group, then we can estimate the capacity of pile group, which is equal to efficiency of pile group multiplied by sum of capacities of all the piles. So this is also similar problem. Here it is clay soil. Here we have to consider both the criteria for individual pile failure and block failure. Then we have to estimate the capacity of the pile group based on both the criteria, and then we have to compare those two values, and smaller one will be reported as the capacity of pile group. So here it is asked to find whether the failure would occur with the pile acting individually or as a group. So we have to consider both the criteria and then we should check whichever is lower. So here the capacity of the pile group based on the individual pile failure is less than that of the capacity of the pile group based on the block failure criteria. So therefore we can write the comment as the failure would occur with the pile fails acting individually. So whichever is smaller, so with that criteria the pile may be failing. Another example, a 25 pile group is arranged in a uniform pattern in clay. Determine the optimum spacing of the piles, assuming each pile to be square in section of side A. Assume coefficient of adhesion as 0.8, unit weight 18 kN per meter cube and adhesion equal to 50 kPa. So here in this problem we have to find the optimum spacing. So here size of the pile is not given, even the spacing is not given. So we have to assume some values for the size as well as spacing. Then we have to consider the individual pile failure, and then we have to estimate the capacity of the pile group based on the individual pile failure. Then by considering the block failure, we should estimate the capacity of the pile group. So then we have to compare these two values, and smaller one will be taken as the capacity of the pile group. Then we have to equate this value to the capacity of the pile group based on the block failure criteria, because in the block failure equation only the spacing is there in terms of Bg. So here we have to find the Bg value, which is equal to 4s plus d. Then from this we can find out the value of spacing. So here we have to estimate the settlement of the pile group. All the details are given, like pile diameter, spacing, then soil properties, thickness of clay layer is given as 13 meter. Even the load on the pile group is given as 200 kilonewton. So here we have to estimate the consolidation settlement because it is clay soil. So in case of clay soil, we have to assume that it is acting like a raft footing from a depth of 2/3 L from the ground level. So at a depth of 2/3 L from the ground level, we have to assume that this pile group is acting like a raft footing with a 2:1 distribution. So from the base of the footing, the load is distributed in 2:1 manner. So if we consider the 2:1 method, then increase in effective stress equal to load divided by area of the soil on which the load is acting. So here sigma naught dash is the initial effective overburden pressure and delta sigma dash is the increase in effective stress. So here 2/3 L. L value is length of the piles is given as 6 meter. So 2/3 L will be 4 meter. So this is 4 meter thickness. So remaining will be 2 meter. And since the thickness of clay soil is 13 meter, this is 4 meter. So remaining is 9 meter. Since 9 meter thickness is too high, we have to divide it into a number of layers. So here we can divide it into 3 layers of 3 meter thickness. So when we divide it into 3 layers of thicknesses 3 meter each, then we have to find the sigma naught dash and delta sigma dash corresponding to the center of each layer. So at the center of first layer, that is at a depth of 4 meter plus 1.5 meter, that is 5.5 meter. So for 5.5 meter, we have to find the initial effective overburden pressure, that is 5.5 into 15. So it is coming as 82.5. Then for the second layer, that is at a depth of, this is 6 meter plus another 1 meter plus 1.5 meter. So total it is 6 plus 2 plus 6 plus 1, 7 plus 1.5, 8.5. So at a depth of 8.5, again we have to find the initial effective overburden pressure. Then at the center of the third layer also we have to find the initial effective overburden pressure. Then to estimate the increase in stress, we have to consider the depth from the base of the footing. So from the base of the footing to the center of first layer it is 1.5 meter. For the second layer it is 4.5 meter. And for the third layer, that is from the base of the footing to the center of third layer, it is 7.5 meter. Then by substituting these values in this equation of 2:1 method, increase in effective stress equal to load carrying capacity or load on the pile group, that is 200 kilonewton divided by Bg plus Zi. Bg value is nothing but width of pile group, that is 2.1 meter. So 2.1 plus for the first layer Zi value is 1.5 into Lg. Here Bg and Lg are same, so we can take it as the Bg plus Zi square. Then we can find the increase in effective stress. Then using the consolidation settlement equation, we can estimate the settlement of that particular layer. So CC value is given as 0.4 into H naught. H naught value is 3 meter. For the first layer, the thickness is 3 meter. So 0.4 into 3 divided by 1 plus E naught is 0.9 into log to the base 10. Sigma naught dash is 82.5 plus delta sigma dash is 15.43 divided by sigma naught dash, that is 82.5. So that we can find the settlement of first layer. Similarly, for second and third layers, we can calculate the settlement. Then we can find the sum of these settlements, which is nothing but the settlement of pile group. So here also we have to estimate the settlement of pile group, but here the soil type is different. Here it is a sandy soil and the settlement of single pile is given as 6 mm. So in case of sandy soil, settlement of pile group equal to SI into 4Bg plus 2.7 divided by Bg plus 3.6 whole square. So here Bg is the width of pile group, which is 2.1 meter, and settlement of pile group equal to settlement of single pile, that is 6 mm, 6 into 4 into 2.1 plus 2.7 divided by 2.1 plus 3.6 whole square, which is coming as 22.75 mm. Then we should find the value of 16 times that of the settlement of single pile, which is coming as 96 mm. So that now we can say whether it is less than or greater than 16 times SA. So here settlement of pile group, which is 22.75, is less than that of 16 times that of settlement of single pile. So it is safe.